This section is on the chi-square test for independence. So in this section, we will learn how to test if there is a relationship between two variables, meaning they are dependent, or if there is no relationship, meaning they are independent. And we will be using matrices or tables for this chi-square test. So this is a matrix with dimensions 3 by 4. So essentially, it's just a table with 3 rows and 4 columns of numbers. And the test is similar to the chi-square test for goodness of fit. So instead of having an observed list and an expected list, we have an observed table and an expected table. So to find the expected frequency, we have to take the row total, multiply it by the column total, and then divide it by the grand total. So the chi-square test for independence is used to test the independence of two variables. We can determine whether there is an association between the row variable and the column variable in a contingency table. The first step is to verify that each expected frequency is at least 5. The second step is to state the claim. Third, we have to state the null hypothesis and the alternative hypothesis. Now the null hypothesis always states the variables are independent, while the alternative hypothesis always states the variables are dependent. Next, identify the level of significance, the degrees of freedom, and the degrees of freedom are equal to the number of rows minus 1 multiplied by the number of columns minus 1. And very importantly, we do not count the totals or the label rows and columns. And then finally, the critical value. Now, just like the previous chi-square test, chi-squared is equal to the sum of the observed values minus the expected values squared divided by the expected values. The last 3 steps are also the same. And again, we will not be solving by hand using p-values. However, we will be using p-values with the calculator. The following contingency table shows the observed results of 500 people classified by their age and their favorite way to eat ice cream. Calculate the expected frequency for each cell. At alpha equal to 0.01, can you conclude that the favorite way to eat ice cream is related to age? Use the rejection region method and show all work. So to find the expected frequency for each cell, we have to take the row total multiplied by the column total and divide it by the grand total. So for this cell, we have to take 50, multiply it by 240, and divide it by 500. And that's equal to 24. For this cell, we have to take 50 multiplied by 260 and divide it by 500. And that is 26. For the third cell, we have to take 450 times 240 divided by 500, which is equal to 216. And for the final cell, we have to take 450 times 260 and divide it by 500, which is 234. And all of these expected frequencies are at least 5. The claim is that the variables favorite way to eat ice cream and age are dependent. So this is the alternative hypothesis. So the null hypothesis is the variables are independent. Alpha is 0.01. For the degrees of freedom, we have to take the number of rows minus 1 and multiply it by the number of columns minus 1. And we do not include the totals or the labels. So there are 2 rows and 2 columns. So 2 minus 1 times 2 minus 1, which is 1 times 1, which is 1. The critical value, if we look at the table, is 6.635. Now, to find chi-squared, on each of these cells, we must take the observed minus the expected squared, and then divide it by the expected. So this can be a large calculation. On the calculator, I'm going to type this all in one line. So it's going to look like this. And it's equal to 1.425. So the picture looks like this. Chi-square would go right there. So chi-square is not in the rejection region, which means we fail to reject the null hypothesis. And the conclusion would be, at the 0.01 level of significance, there is not enough evidence to support the claim that the favorite way to eat ice cream and age are dependent.